So I thought I'd show you that you could do these graphs on Desmos as well. So here's how the syntax works. You just do parentheses like you were doing point coordinates, and then you put in your function. We got a sine of 2t for our x, so it goes first, of course, because x is first. Now, so here's what you got to do. You have to put in t for the variable. So you hit the ABC, or you can use, if you're on your computer, you just use your keypad and just type a letter t. But it wants the variable to be t, the independent variable. And then we hit a comma, and then we do cosine of t. So functions cosine. And then we got to go back and get the t again. And then close the parentheses. All right, and then what you see is that there pops up a domain for t right there. So we want to adjust that to be 0 to, in this case, 2 pi. We could have it be, there's sort of an interesting thing there, isn't it? If I only do 0 to 2, I only get this much of the picture, about a third of it. So when I do 0 to 2 pi, I get the whole picture. All right, and then here's the tangent line that we figured. Where's my tangent line? There it is. Didn't want to do it. So there you go. That's pretty nice, right? Pretty nice figure. All right. So the next thing that is going to happen is you are going to do some work on page 153. So I'm going to demo one of these problems. We're going to do page 153 in your book, which just asks you to find the equation of the line tangent to the curve, and gives you a bunch of parametrically defined curves and some points at which they can happen. I thought I'd do one a little bit different, 2t squared plus 3 and t to the fourth. So we have y, this is number 46. Let's put this right. X equals 2t squared plus 3, y equals t to the fourth, and we have t equals -1, and we're asked to find the equation of tangent. Find equation of tangent. All right, so we want to use dy dx equals dy dt over dx dt, so we need to find out, my cat sounds like he's going to have a heart attack up there, what x prime and y prime are. So x prime is 4t, y prime is 4t cubed. So that means that dy dx equals, the y prime goes on top, 4t cubed over 4t. And now that reduces nicely. We want t equals -1, so we don't care about t equals 0. So we can just call that t squared. All right, so, for t not equal to 0. So in particular, dy dx evaluated at t equals -1 is equal to -1 squared, so it's 1. Now, to write the equation of the tangent, the other thing that we need is x of -1 and y of -1. It did say -1, right? Yeah, okay. X of -1 and y of -1. So x of -1 is 2 plus 3, so it's 5. And y of -1 is 1. All right, so that gives us the 0.51. So we're going through the 0.51, and our slope is 1. So this is our slope. This is x1, y1. So we can write our equation of the line. Y minus 1 equals 1x minus 5, or just y equals x minus 4, right? Y equals x minus 4. Let's see what that one looks like, because I'm just sort of curious with these polynomials, what that's going to look like. So let's see, we'll kill this one and this one. And we'll look at 2t squared plus 3. So, so we're going to go comma 2t squared plus 3, comma t fourth. So t fourth. All right, now it starts out only giving us t 0 to 1. And a lot of times when we have these like polynomials, what we really need is like a really broad range on t. Let's do -100, because we know that we need t equals -1, to +100. So that's just like a time. Now, I don't see anything, so let's zoom out. Oh, there it is. There it is. All right, now we want it t equals 1. Oh, t equals -1. Oh, that's interesting. How do I know where t equals -1 is? So the only thing, right, it's not x equals 1, it's not y equals 1. So we know that at t equals -1, the point we're really looking at is 5, 1. So here's, here's 5 right there. And so there's 5, 1 is this point right there. So let's go ahead and put in the tangent line at that point, which is x minus 4. So x minus 4. So it's just, just look at that. Yeah, it looks like a nice tangent line, doesn't it? How nice. Okay, so your homework for this unit is, so first of all, the Parametrics lab. All right, so that means all of this with the picture, okay? Notice that in the picture, you are supposed to find dy dx and graph the tangent line. Your picture has to have a tangent line on it, okay? And then the other thing, there's another page to this. Yes, of course I'm not going to be able to find it. So the other page just asks you for a bunch of sketches. So the other page asks you to just plot these using your calculator. You can use Desmos if you want. And then it says to, it just says produce graphs, okay? So what I want you to do for each of these is just give me sort of a rough sketch. Like you don't have, like if I were to do the one that we've just been doing, I would just go like that. So it looks like that, right? So just rough sketches. Give me a rough sketch on each of those. All right, and then the other thing that you're going to do is page 153, number 41 through 47 odd, and those are going to look just like this. And there you go. Now you know a tiny fraction of everything you're about to learn next semester about parametric equations.